Hello, my name is Montana Jackson and my project is in-home water distillation. I chose this topic because water can be distilled in a universal way that is both easy and done in limited environments. Worldwide, 780 million people do not have access to an improved water source. The focus of this science project is to compare the different methods of distillation of water from an aqueous solution, example, salt water or dirt water, with a in-home apparatus filter. Clean water can be made in the convenience of the home. With water distillation, the most user-friendly is simple distillation. Single membrane distillation is a form of simple distillation. If I distill water 3 different ways, use bottles and solar energy, pot in a bowl, and a kettle with a pipe, then one will be the best way to distill water with the most purity for an in-home water distillation. My hypothesis is that the kettle and the pipe will produce the most purified water, even though it's the most complex of the 3 methods. I have made my charts bigger so they are easier to see. The first method was the pot in the bowl. I used a kitchen pot and a glass bowl. I taped the bowl on top of the pot and put the lid on top. The purity of the dirt water was better than the salt water, but the inconsistency was troubling. A method is needed that will distill different aqueous solutions the same. The visual of the water proved there was a change, but the chemical oasis was troubling. The molecules didn't break to separate the salt and dirt from the water to make it consumable. The contaminated water was in the pot, and as the steam rose, the clear water droplets attached to the lid and fell into the glass bowl. This is the salt residue from the salt water. So the visual separation was there. Another problem that is crucial that is so much steam was released from the side of the lid that a great amount of water was lost, affecting the amount of clean water that was collected in the end. The second method was the solar power with recycled plastic bottles. I put holes in the caps of the bottles and glued them together. Then I screwed the bottles on each end and added tape around the caps. This method resulted with the best and most consistent results. Although the water was not the clearest, the chemicals did their job of breaking apart and making hard water from both of the aqueous solutions. Hard water is not ideal, but it is still consumed by many. It is found in wells. Another good outcome from this method was that the bottles were compact and the steam was not released. This is the apparatus outside receiving solar energy. The right bottle is the salt water before the water was distilled, and the left is after. There is little visible difference, but the murkiness is still there. The left bottle is the dirt water before water distillation, and the right is after. The visible murkiness is still there. But with both products, hard water was created, which is consumable. The third method was the kettle and pipe. This was the method I agreed with for my hypothesis, but I was proven wrong. The same results and problems occurred with pot and bowl. For this method, I used a kettle and CPVC piping, the same used for water heaters. I used liquid cement to attach the piping. The steam goes up the pipe and perpendicularly goes down into the mason jar. This is the salt water before. Steam was again escaping out of the pipe and kettle, affecting the amount of clean water collected at the end. The visible water after the distillation was clear, but the inconsistency of the chemical breaking molecules was bad. My hypothesis was proven wrong in the end by the success of the second method, solar energy. I chose the kettle and the pipe method, thinking that the piping would be able to apply enough pressure. The second method, which is the solar energy, produced hard water, 160 parts per million and 190 parts per million. That is not the ideal drinking water, but was the best results in this experiment. The second method was the least expensive method, using recycled plastic bottles in the sun. With the plastic bottles being screwed and taped on tightly, it kept the pressure tight, and air and steam wasn't released, which is something that the first and the third methods failed at. The only bad part about the solar method was that it took the longest time to complete, which was 2 to 3 hours. It was easier to remove the salt from the water than the dirt. Looks can be deceiving in the appearance of the products of water distillation. There were cases that the water looked clean, but the TDS quality water tester detected that it was not the cleanest to consume. Also, in some cases, the water had a tint of yellow or brown, and the TDS water quality tester detected it as average or hard water. It was very hard to get perfect drinking water. However, these methods did make the original contaminated water less dangerous to consume. For example, some products resulted in hard water, which has high minerals, which is great for washing hair, which is a fun fact. This experiment could have had many adjustments that could have possibly made the outcomes more successful. One of the main purposes of this project is to make an inexpensive, in-home water distillation. So producing ideal water is an arduous task without heavy machinery. With the first and third methods, too much steam was being released out into the open air. The weather outside, which was windy, moved my solar water bottles around, making it unstable. I wish I had a different place to perform my experiment besides my own kitchen, because the steam and the smell of dirt burning filled my kitchen. Well, anyways, thank you for watching, and my name is Montana Jackson, and this is In-Home Water Distillation.